Hi, my name is Daniel. I'm a Senior Principal Product Manager for Cloud Migrations at Oracle. Before joining Oracle, I worked for a global provider of financial services as an operational DBA and developer. I'm excited to be here today to talk to you about AutoUpgrade 2.0. If there is only one thing that I want you to remember from this presentation today, it is that you should always use the latest version of AutoUpgrade. In your Oracle home, you will already find a version of AutoUpgrade, but chances are that that version will be much older than the one that we offer on My Oracle Support. So it's really shame to miss out on those new great features and having to hit a known bug. So get rid of your old version and use the latest one from My Oracle Support. When you use AutoUpgrade with the minus version command line option, you'll see something like this. Here you can see it's version 22, but don't worry. If you're upgrading to an older version of the database, let's say for instance Oracle Database 19c, you can still use a much newer version of AutoUpgrade because AutoUpgrade is fully backwards compatible. So another argument for using the latest one. These are the features that I would like to present today. First, we're going to talk about AutoUpgrade patching. When we launched AutoUpgrade a few years ago, the feedback from you was quite good. You really loved what we did to upgrade. Many of you came to us and said, we really love how easy upgrade has become. Can you do the same with patching? And we heard this over and over again. And we listened to you, and now I'm proud to present that AutoUpgrade is now capable of patching your database as well. The experience when you patch your database is very similar to that of an upgrade. First, you, yourself, must install the Oracle Home. So go to oracle.com, get the base release. Remember to put the latest release update on top of that. And go to 555.1 and find the monthly recommended patches to put on top as well. Now you have an Oracle Home. Now you need to create a configuration file. You can create a simple one or use some of the advanced features in AutoUpgrade. And then finally, just kick off AutoUpgrade in deploy mode and it'll patch your database. This is an example of a very simple configuration file. As you can see, there is no magic switch that turns on AutoUpgrade patching. You just specify the source and target Oracle Home. AutoUpgrade will examine the two homes and determine whether a patch apply is needed or an upgrade. Now this is a simple example of a configuration file, but you can use all the advanced features in AutoUpgrade, put those into your config file, and it'll work as well. When you patch your database with AutoUpgrade, it is the same familiar experience as when you do database upgrades. You still have the AutoUpgrade console where you can monitor the progress of the operation and interact with AutoUpgrade. And then underneath the hood, we don't hide anything as well. All the log files from the patching operation is stored in the file system. And of course, AutoUpgrade also protects your database. As with Upgrade, it'll set a guaranteed restore point before touching your database. This ensures that we can always get back to the starting point if something bad happens. In the absence of a guaranteed restore point, AutoUpgrade can also use data patch rollback functionality to bring the database back in the previous state. And of course, everything is automated, including all the srv-ctl command, updating etc aura tab, and moving files around. It's the same end-to-end experience as when you do upgrade. You can use AutoUpgrade patching together with all the other advanced features in AutoUpgrade. Later today, I'll show you two new features, Refreshable Clone and Distributed Upgrade. They're really cool features, and of course you can use them together with patching as well. We were very excited to show you this new feature, which means that we had to cut a few corners. Currently, it doesn't work on Windows, but we are working hard on fixing that. If you have a RAG database and want to perform a true rolling patch apply with no downtime, you still have to use OPatch Auto. And in your DataGuard environment, if you want to use AutoUpgrade, you can use that on the primary database as part of a standby first patch apply, but the entire process is not automated. And similar to an upgrade, you have to do all the operations on the standby database, and then AutoUpgrade will take care of the primary database. If you have one database to patch, or a few, or perhaps a handful of databases to patch, you can use AutoUpgrade. Of course, it'll also work with even more databases. But as soon as you go kind of fleet scale, it might be time to investigate fleet patching and provisioning. So these two tools are not competing against each other. They are complementing each other very well. Once you go really big with fleet patching and provisioning, you also get the benefits of being able to deploy the Oracle homes as well from the same centralized tools. But enough about patching. The next is refreshable clones. This feature is very useful when you need to not only upgrade your database, but also perform non-CDB to PDB conversions. As you probably already know, the non-CDB to PDB conversion is really irreversible. As soon as you plug in your database as a PDB, changes are made to the data file headers that are completely irreversible. Not even flashback database can save you. So what are your fallback options in that scenario? Typically, you might look at something like backup restore or copying the data files as you plug them into the database. When you copy the data files, you need a lot of time if the database is really big, and you also need disk space. With this new feature, Refreshable Clones, we have taken out the time part when you copy the data files, because we can simply copy the data files without any downtime. We will copy the data files in advance and keep them in sync with redo from the non-CDB database. This is an overview of the process. First, AutoUpgrade will create a new PDB in the target container database, and it'll copy the data files from the non-CDB database. And there is no downtime here. We do it all in advance. Then we grab all the redo from the non-CDB database and keep the PDB in sync until you are ready to perform the final cut. When you want to convert the non-CDB database into a PDB, we must take an outage. Then we can do a final refresh before we convert the database into a proper PDB. For this to work, there must be a user in the non-CDB source database, and it must have a few privileges. In the target container database, you create a database link that points back to the non-CDB database. Then in the AutoUpgrade configuration file, you simply specify the name of the database link. This will tell AutoUpgrade to go to the source database and fetch the data files and put them into the PDB. Optionally, you can specify the refresh rate. Here it's 300 seconds. So this means that the target container database every 5 minutes will take the redo from the non-CDB database and apply it on the PDB. But of course, before we kind of make the cut and prepare the PDB for the final conversion, we will do a final refresh. So this refresh rate is just to keep the sync flowing at a regular interval. And you can also optionally specify a start time. This is very handy when you want to control exactly at which point in time that there is downtime. This is an example of a workflow in AutoUpgrade. When you start AutoUpgrade in deploy mode, it'll create the PDB, it'll copy over all the data files, and it'll continue to take the redo and apply them on the target PDB. At the time specified by the start time parameter in your config file, then we have downtime. Now we need to cut the link between the non-CDB and the PDB, perform a final refresh before we convert it into a proper PDB. And the really cool thing about this is that we don't touch the non-CDB database at all. This means that your fallback options are very good. You simply have the non-CDB database left there intact. So if something happens, simply bring up the old source database and you are good to go. This also works for unplug-plug upgrades. So when you have already converted your database into a PDB and you want to upgrade to the next version, you can use this feature, Refreshable Clones, as well. So you can unplug a PDB from one container database and into the other, move it to a different host, for instance, with no downtime or very minimal downtime. Next up, we have encryption. These days, there's a lot of focus on security, and especially with the cloud adoption, in OCI, we mandate that your database is encrypted, and that's why TDE tablespace encryption is part of the deal. And the good news is here that AutoUpgrade is now fully supporting your encrypted databases. This was not the case previously. To understand why, let's look at some of the commands that AutoUpgrade are executing on your behalf. For instance, on the create pluggable database statement, there is the key store identified by clause, which is needed on encrypted PDBs, and we must have the database key store password in order to input the new TDE encryption keys. So there are many operations where AutoUpgrade must know the database key store password. You, as a user, can supply the database key store password, but AutoUpgrade must have a safe place to store that password. It is sensitive information. We have solved that in two ways. If your database is configured with a secure external password store, AutoUpgrade will automatically detect that and use it accordingly. In the absence of such, AutoUpgrade now has its own dedicated key store. In advance, you can input sensitive information like database key store passwords. And now AutoUpgrade can hold them safely in its own key store until a later point in time when it needs to use the key store password to complete, for instance, an unplug upgrade of an encrypted database. When you are working with encrypted databases, there is one configuration file parameter that is very important, and it is global.keystore. It points to a folder in the operating system where AutoUpgrade can place its own key store. AutoUpgrade's key store contains sensitive information, so you must protect the folder in the operating system accordingly. Once you've done that, you can simply analyze your database. AutoUpgrade will connect to the database and examine. If it finds that it is encrypted, it'll, in the summary report, tell you exactly for which databases that you need to do something. In the below example, for instance, you can see that for two databases, CDB1 and CDB2, you must input the database key store password in advance. But once you've done that, it is simply to just hit the deploy button and AutoUpgrade will continue. I've prepared a demo where I can show you this. I'm upgrading an encrypted non-CDB database and converting it into a PDB. So let's see how it works. I set the environment to the source non-CDB database. You can see that it has an encrypted tablespace. This is the AutoUpgrade configuration file. I'm upgrading a non-CDB database to 19C and I convert it into a PDB as well. The database is encrypted, so I need to specify the global.keystore parameter. Now let's analyze the database. After a little while, the analysis completes, and I can check the summary report for details. I can see here that pre-checks is in status failure. There are some manual things that needs to be taken care of, and it's related to TDE key store passwords. Let's have a look at the pre-upgrade log file. I scroll down to the required actions before upgrade. AutoUpgrade has determined that database key store passwords are required for the source non-CDB database and the receiving target container database as well. So first I'll add the database key store password for the source non-CDB database, and I use the load password command line option. It is the first time that AutoUpgrade uses its own key store, so I have to provide a key store password. Then I can add the database key store password for the source non-CDB database. I save the information into the AutoUpgrade key store, and I choose to convert it into an auto login key store, so I don't have to specify the password for anymore. Now I must deal with the target container database. And here I want to use a secure external password store, but it hasn't been configured yet. So I go ahead and do that by setting the external key store credential location to the directory in the operating system where I want to create the secure external password store. It's a static parameter, so I need to restart the database. And then I can add the database key store password into the secure external password store so the database can use it whenever it's appropriate. Now let's try to reanalyze the database. Notice here that no key store password is required for the AutoUpgrade key store because I created an auto login key store. After a little while, the analysis completes. Again, I check the summary report. And now there are no issues. No manual intervention is needed. I input the database key store password for the source non-CDB database, and the target container database has a secure external password store. So there's nothing to worry about. Now I can go ahead with the upgrade and the PDB conversion, and I start AutoUpgrade in deploy mode. It'll run for a while, and eventually the job completes. Now DB12 has been upgraded to 19C and converted to a PDB and plugged into CDB2. But let's verify that. I can see here that the DB12 PDB is open in read-write mode and unrestricted, so that looks good. I can also verify that the encryption tablespace is still there. And that's it. That's how you upgrade an encrypted database and convert it to a PDB as well. Great. The next feature is Distributed Upgrade, which is a performance enhancement for RAC databases. In short, Distributed Upgrade allows you to use all the nodes in your RAC cluster when you upgrade a container database. The result is that we can upgrade an entire container database much faster than it used to be. Previously, when you upgrade a container database, it looks like this. On node 1, first, AutoUpgrade must upgrade the root container, and it does so with cluster database set to false. When this parameter is set, only one instance of the RAC database is allowed to be started. After the root container, all the PDBs are then upgraded in parallel. But look at node 2 in the bottom. It is just sitting there absolutely idle, doing nothing. With Distributed Upgrade, we've changed that. First, we still need to upgrade the root container, and we must do that with cluster database set to false. So here only one instance is in play. But as soon as the root container has been upgraded, the RAC database is restarted and cluster database is set to true again. And now we can start more instances of the same RAC database and then process all the PDBs in batches on the various nodes in your cluster and thus perform the upgrade much faster. In the AutoUpgrade configuration file, there is one setting that you must enable in order to use this feature. Distributed Upgrade equals true. Set that as a tune setting, and AutoUpgrade will then do all the magic for you. We were super excited about this feature because we could immediately see that there was quite a good performance gain from this. So we decided to make a benchmark. We took a 2-node RAC database with 4 CPUs each and a container database with 8 PDBs. We were able to knock off 41% of the upgrade duration just by enabling this feature. And we do expect that it scales quite well. So if you have more nodes in your RAC cluster or if you have more PDBs in your container database, you should be able to get some really exciting numbers. By default, when you use Distributed Upgrade, AutoUpgrade will use 2 nodes. But if you have more instances in your rack cluster, you can use as many nodes as you want. You can simply change the active nodes limit and then specify how many nodes should be used as part of the distributed upgrade. And that's all it takes. Simply to just start AutoUpgrade in deploy mode, and it will then fan out on multiple nodes in your cluster. If you have a really big container database with many PDBs, for sure, one or two or more of the PDBs are more important than the other. So let's look at how we can control the order of the upgrade of each individual PDB. Normally, when you upgrade a container database, there is a parameter called make PDBs available, which defaults to false. With that setting, what happens is that when the PDBs are upgraded, all of the PDBs will stay unavailable. The users cannot connect to the PDBs until all PDBs have been upgraded. In this example here, we can see that PDB 1 finishes first, but it has to sit there waiting without being able to serve the users until all the PDBs, in this case PDB 4, has been upgraded. Now you can change that. If you set make PDBs available true, what will happen is that as soon as PDB 1 has been upgraded, it'll become available for the users to connect to it and use it. Similar, when PDB 2 is done, it'll become available, and then each individual PDB will become available to the users as soon as they are upgraded. So if PDB 1 is very important to you, you can shorten the downtime, make it available to users much faster by setting this parameter. In order to control the priority or the order of the upgrade, on the alter pluggable database statement, there is a priority clause. Here you can specify the priority of each individual PDBs. The lower the priority, the sooner the PDBs will be processed by AutoUpgrade. So in this case here, we have the sales prod PDB, very important PDB, and we want that to be upgraded first. So we set priority to 1. In contrast, we have the sales test database, which is not really important to us. So here we can set priority to 3. But there is something you need to be aware of. When you use the parameter make PDBs available and set it to true, what will happen at the end if PDB 4 crashes during the upgrade? At this point in time, PDB 1 has already been upgraded. Users are already logged on to PDB 1 and has made changes to that database. The restore point that protects the entire container database is set on the CDB level. So this means if something happens to PDB 4 and you decide to flashback the database, you will flashback the entire CDB, and thus you will lose all the data that has been entered into the previous PDBs. In a future version of AutoUpgrade, we will be able to set per PDB level or set restore points at PDB level, but for now there is one guaranteed restore point and it covers the entire container database. And finally, we have some usability enhancements. And what better way of showing you how those enhancements works by doing a demo. This is the AutoUpgrade console. If you are familiar with AutoUpgrade, you already know the lsj command. If I want to repeat the last command, I can simply use /. To monitor the progress of an upgrade, you probably often run lsj multiple times. And we now have a good way of doing that, by using the -a option and then specifying a repeat interval. In this case here, the lsj command is re-executed every 10 seconds. That's a very handy way of monitoring your upgrade. I can use H or history to list the previous commands. When I found the command of interest, I can use / and the corresponding number to re-execute the previous command. Another new command is fxlist. it'll show the pre-upgrade and post-upgrade fix-ups that AutoUpgrade deemed necessary to execute for this specific upgrade. Imagine that I don't want to upgrade the time zone file. I can now edit the list of post-upgrade fix-ups by specifying first the database, and then the fix-ups, old time zones exist, and run no means that I want to disable that specific fix-up. If I check the list again, you can now see that old time zones exist. That fix-up will no longer be executed. This is a summary of the commands that I used in the demo, but there is one new command, the second one, status. Similar to the lsj command, on the status command you can also use the -a option. Here, specify a refresh interval, and the status command will then repeat itself, just like you saw in the demo with the lsj command. Thank you for watching this session about AutoUpgrade. My name is Daniel, and enjoy the rest of Oracle CloudWorld. Thank you.